Hi everyone, this is Dr. Swaminathan Yasam, Associate Professor, EC Department, SNS College of Technology. Now I am going to discuss about the topic called stability analysis. So first, what do you mean by stability? So we need to identify the system's stability based on the transfer function. For example, transfer function means transfer function is equal to zeros divided by poles. Okay, so first you need to find the poles, whether it is placed in the left hand side of the S plane or right hand side of the S plane. So poles means that is denominator of the transfer function. So denominator is equal to 0, you just to make it, and if the poles are left hand side means then it is stable of the system. Next, if the poles are positioned in the right hand side of the plane, then it is called instability of the system. So first thing, introduction about the stability. This is the introduction about the stability. And next, what are the types of stability? And in the types, absolutely, marginally and conditionally. These are all the stable system. So first, the stability, that means a system is to be stable if its output is under the control, otherwise it is set unstable. So output must be controlled means based on the inputs, based on the input variations or state variable, only we can control the output. So a stable system, it produces the bounded output for the given bounded input. So x-axis means 0 to t and y-axis 1 means this unit step input. That is a continuous time signal. And the types of stability, the stability is furtherly divided into 3 points. One is absolutely stable system, and another one is conditionally stable system, and the third one is the marginally stable system. So absolute stable system means the system is stable for all the range of the system component values, then it is known as absolutely stable system. So you can divide open loop system and closed loop system. Open loop system is absolutely stable means all the poles of the open loop system function presents left hand side of the plane, that is S plane. And similarly, you just replace the word open into close. So the closed loop system is absolutely stable if the poles of the closed loop system transfer function that is present in the left hand side of the S plane. And next, the marginally stable system. If the system is stable by producing the output signal with a constant amplitude and frequency of the oscillations for the bounded input, then it is called the marginally stable system. The open loop control system is marginally stable if any two poles of the open loop transfer function is present on the imaginary axis. And the same thing, closed loop system is marginally stable means if any two poles of the closed loop transfer function is present on the imaginary axis. And next, conditionally stable system means if the system is stable for a certain range, that is, it's called as conditional. Conditional means it's a certain range of the component values, then it is known as the conditional stable system. So you can look at the stable system. So left hand side means that is asymptotically stable, and right hand side means that is the first thing marginally stable, and above unstable, that is the repeated poles for imaginary axis, and the right hand side the real axis means that is placed in the real axis. If cross mark mentioned means that is poles, zero mentioned means that is a round symbol mentioned for zeros. So based on the positions of the poles, you can decide whether the system is stable or unstable in the S plane. So S plane means x-axis means real axis S, and y-axis means that is the imaginary axis j omega. So this is called the summary of the stability of the system. So first thing, you must know the summary, important point of the stability. The input is controlled, output, that is called the stable. So you can control the input based on the loop gain of the transfer function. So any loop gain, so for example Bode plot or polar plot, everything is based on the transfer functions gain, so loop gain. So next, based on the transfer function, you can decide zeros and poles. So poles means that is downside, that is the denominator side. So you just equate the denominator side equal to 0, then you can get the poles. So if the poles are placed in the left hand side of the S-plane, then it is called, that is unstable. Left hand side of the system means that is called stable, and right hand side of the S-plane, that is called unstable. So this is the stable system. Next, marginally stable. Next, conditionally stable. Conditionally stable means certain condition, certain range, that is called the conditional stable. So this is the summary of the today's session, that is stability of the system. Thank you.